Hello and welcome to the show. So all day long I've been preparing this troubleshoot exercise which was given to me by one of the lecturers at my local university. They're doing a class on troubleshooting. So the premise is basically you're given a topology and you have to work out what's wrong with this topology. Last week it was based on spanning tree layer 2 issues. And today, it's more of the same. So we're giving these Cisco packet tracer labs, which, and you can see on the screen there, is running away. You've got 3 catalyst switches, 3650s, 2960s in this ring. These 2 cables are channeled together in an EtherChannel, a PortChannel group. So each switch has 2 groups. And 3560 and 3560 there are running PortChannel 10, and the 3560 to 2960 is PortChannel 1, and then this 3560 is PortChannel 2. So that's all okay. And then at the top we've got these 3 routers here, and these are just iOS routers, 1800 series, and they're going to be running over some serial links, PPP encapsulation, IP, EIGRP. So fairly simple, but I guess feature rich. There's a lot going on there for a small lab in a troubleshooting exercise that you're supposed to complete within a space of a few hours, I guess. And I'm fortunate enough to know a little bit more about this than some of the other people in the class, but that's not to say that it's not an easy thing to do well in a fixed time, because you've got to go into each device. You need to understand how the device has been configured, then you need to document each thing, then you need to make the changes based on your assessment of the information, and then you need to report on that. So it's an awful lot more writing than reading, but the point is it's a troubleshooting exercise. So how do you approach this problem? So what is the problem? The problem is defined to the student as clients in VLAN 10 cannot see services on server 1. So from PCB on this diagram here, you cannot see services running on server 1. And server 1 is a virtualized, not virtualized even, like a software driven platform within Cisco packet tracer. It's got a web service, it's got a syslog service, radius service. It's pretty neat. The PC is just a simulated PC environment. So with this topology running, you're supposed to have a problem with traffic running from PCB to server 1. That said, if you pop onto PCB and try and connect to server 1 on IP address 10.1.50.1, this should fail. Okay, so where do you begin with your troubleshooting in this environment? But look at that, the pings begin. So as a student in this class, you load up this environment, you're given a bunch of text files with the configuration for each device, you copy and paste those text files directly into each device, and then you begin your troubleshooting. But it works. So I raised my hand, and the instructor came over, and I told him that it worked. And after a few minutes it was clear that what had happened was the configurations which we were given are not compatible with Cisco Packet Tracer. Why? Because the problem with the lab should have been that the 2960 had a multiple instrument spanning tree mode set, whereas the 3560s had rapid per VLAN spanning tree set, and they're incompatible. Plus, there was some encapsulation issue with the trunks on the port channel. So there were 2 distinct faults. Both of those faults were negated by the fact that the Cisco Packet Tracer, number 1, didn't care what encapsulation you ran. It doesn't support that. And 2, the multiple instance spanning tree is also not supported. So once the configurations were pasted in, it took the default configuration and everything worked a treat. So what I did instead was build my own topology in EVE-NG using the same sort of setup. We've got the 3 routers, the 3 switches, the 2 PCs and the server, and I'm going to take you through how the lab should have worked if the configurations were taken as they should have been. So let's do that together. Okay, so let's spin up the lab, but before I do that, let's just wipe all of the config just to make sure we're coming up clean. And when I say config, I mean if I've made any changes to these existing startup configs. So each device has a startup config, and the topology information that we're specifically looking at, which were absolutely essential to this troubleshooting exercise, were here inside the port channel, where you see the switch port mode has been set. In fact, I need to take this out. You shouldn't be doing that. Let's take that out. Let's take that out. This one, and this one, and this one, and this one. And what else we got? Okay, so you can see the Spanish mode MST here. Now these should work. So, all right. So there's the broken config. The DLS switches have been set with Spanish tree mode of PBST. So where are we? Yeah, there we go. So you can see there's an incompatibility there. But what you will see is these switches have been set with the right trunk port and encapsulation setup. All right. So let's go ahead and boot all these images. And then when it connects, we'll quickly set the IP on the server 1 and try to check PCB if that has an IP address. So one other thing that was also interesting about the lab, PCB uses DHCP, and the DHCP server is DLS1. So DHCP server is this guy. Okay, so DLS1 is the DHCP server. So the PCB should start up, make a DHCP request of DHCP server. It should then lease an IP address to PCB. And obviously to do that, it needs VLAN connectivity, layer 2 connectivity between the switch ALS1 and the switch DLS1. And obviously it needs some IP on DLS1 to be able to resolve that IP request in that subnet and blah, blah, blah. But the point being, PCB should receive a DHCP address, which it does clearly in the packet tracer config. If you go under, actually I'm not sure if it would show me on there, but if you go under configuration and fast Ethernet, you can see it's a bit grayed out, but IP configuration DHCP, and the IP address 10.1.10.1, so that's the PC's IP address. But on this topology, that won't work because the layer 2 isn't working. So this is the virtual PC simulator. It's not the same as the packet tracer one, but it'll perform the same sort of functionality. Let's run DHCP and try and pull an IP address from the DHCP server. That should fail. At the same time, let's go on to the server 1. This is a Linux box, so it's not this simulated server environment that you see over here. It's actually a real server, or desktop install for Ubuntu. I'm just going to sudo in here. The box doesn't have an IP address yet, but we'll put one in. I'm just going to think what we do. IP address. Is it add 110.151 plus 24 on that interface? And then we'll also add a static route, so IP. Route add default via 10.150.254 dev ENS3 gateway. Okay, so let's do pen 10.150.1, that's me. 10.150.254, that's DLS1. And let's try and ping. Well, the PC won't be able to ping. Let's run it anyway. Let's leave that running. So on the DHCP server here, you can see it didn't get an IP address. Why? Because the layer 2 is down. Part of the troubleshooting question was really the reason why we were troubleshooting this fault. ALS1 has failed. This is the story. So ALS1 has failed, and an engineer has replaced this switch with another switch and configured it with a configuration from the configuration management system or whatever, you know. So they've got an old copy of the config, they've pasted it in, it's not working, and you're being asked to troubleshoot it. So under ALS1, Let's have a quick look. Alright, we're seeing some CDP errors here. A native VLAN mismatch on Ethernet 3. Ethernet 3 is connected to 0/3 is connected to DLS2. Let's just quickly show that the EtherChannel is working. Show EtherChannel summary. Shows us we've got two EtherChannels, port channel 1 and port channel 2. Port channel 1 goes to DLS1 and port channel 2 goes to DLS2. And you can see the member interfaces. So port channel 1 is made up of members from interface 0001, and 2 is made from members 0203. And it's formed and it's running. There's no LACP or PAGP running here. It's just a statically defined ether channel. But we're not running any trunks over that. Any VLANs over that. Let's just quickly look at the spanning tree for VLAN 10. So this VLAN, in fact, let me just show you that one quick. So show interface status will show me a list of all the switch interfaces on this device and the VLANs that they're connected to. And PCB, you can see, is connected to VLAN 10. Okay. We can also do show spanning tree interface and just see what is happening on Ethernet 1.3, and it will show us that we're forwarding and we're running MST. Okay. And we can also show interface fast. No, not fast. Is it fast? Ethernet 1.3 switch port. This will show us more information about the switch port. So you can see we're running access mode VLAN 10, which is called Office. We're also running a voice VLAN 20, which is called Voice. It was configured for static access, and it's actually negotiated static access mode. Alright, so that's fine. But the takeaway here was this VLAN 10. So the PC is going to come online, and the DHCP service is going to ask on VLAN 10 for a local DHCP server to give it an IP address. That's really what's going on. It can't do that. Why can't it do that? Because VLAN 10 is only forwarding through the local port the PC is connected to. So the PC is saying hello, and the switch is basically got nowhere to send that traffic, nowhere to send that DHCP request traffic. So what we really wanted to do is have VLAN 10 and all the other VLANs necessary for functionality, so VLAN 20 as well for voice and whatever else is needed on this switch, to be trunked over these port channels. So if you've got an access link, you know you can have one data path, right, which is the VLAN 10. In a special way, Cisco will allow you to have two, one for voice, one for data. But in reality, if you have an access port, you've got one VLAN on there. And in this case, we've got these two port channels, port channel 1 and port channel 2, and you want multiple VLANs on that port channel, so that is a trunk port. So the trunk port will carry more than one VLAN. Let's just take a look at which interfaces are set up as trunk ports with that command, and we see there are no trunk ports. So now you're thinking, okay, this must be the fault. Let's take a look now at the running configuration. You know, we've not looked at that just yet. So let's have a look at the running configuration for interface port channel 1. And then you go to port channel 1, you see that it's set up to allow VLANs 10, 20, 30, 100 with a native VLAN, like an untagged VLAN, of 900. But you can see that it's not. If you do show interfaces, I'm not sure if the port channel will show this. Let me just quickly look. Okay, great. So you can see that its negotiation trunking is on, but it's actually negotiated static access. It's not trunking. So the other side, there's no negotiation. It doesn't know that it's supposed to be a trunking port. Why? Well, DTP must be disabled. The dynamic trunking protocol must be disabled, otherwise it probably would have come up online, on as a trunking port. So we can fix this in two ways. One is to turn on DTP, which then should dynamically bring the trunk port up, or since it is disabled, which it is, we can physically configure this as a trunk port. We'll go into port channel 1, switch port mode, switch port trunk. We'll set the encapsulation .1Q, and we'll set the mode to trunk, and we'll do the same for port channel 2. Now those are coming online, you're seeing some more error messages about spanning tree, and you can see that it's learning PVST per VLAN spanning tree, whereas I'm MST. So there's a disconnect there. So now we need to change our mode, binary mode to MST. Now, of course, we could set the other two switches to MST, but we know that this switch was the one that was changed. So we shouldn't be changing any other configuration of the other devices, just this one. So we've changed the spanning tree mode, we've set up the interface trunk. So now if we do show interface trunk, we'll see that those two port channels are in trunk mode. We're still not forwarding any traffic yet. Let's show spanning tree VLAN 10 now. And you can see there's something wrong with this circuit. You can see that it's broken, in a broken state, BKN. Yeah? And it's still saying we're still in MST mode for some reason. Spanning tree mode. Oh, I must have typed it wrong. So we'll change our mode back to rapid spanning tree. This will be the same mode as PVST1. Sorry, no. DLS1 and DLS2. So this should now bring those port channels into some consistent state, and with those ports should move into a forwarding state, which it has, and a blocking state, which it has. So you can see port channel 1 there is now forwarding for VLAN 10 and blocking for VLAN 10 on port channel 2. Okay, so now we should have a workable layer 2 network here in ALS1. So PCB now can broadcast out for its DHCP IP address from the server. Let's just get rid of that. Oh, no, I've got the ping running to show you that was running. Let's maybe make this smaller so you can still see the ping. There we go. Alright. Well, look, once it's finally got an IP address, it should start pinging again. So we'll run the DHCP client on the PCB. It should now then broadcast out and resolve the DHCP address from this guy, come back and or not. Oh yeah, there we go. So we've got the request, got the accepted of the IP address, and now 10.1.10.1 is my IP address. Still not pinging. 10.1. Okay, something's happened to the stack on the. You know, I keep setting the IP address and then it just fails for some reason. Anyway, there we go. All right, so I had to reapply the IP address, reapply the default route on the Ubuntu box there, but you can see now you can ping PCB. So that was it, and that was the whole challenge. But the real shame of this was that the configuration that we were given was not at all applicable to the lab environment that we were given. I had to then port it over to this one, and you can see that's flipping fell off again. Don't know why it keeps doing that. It is fine. It just keeps losing its state. There must be some configuration in here that I've not got quite right. It is a virtual machine, so I'm probably just messing it up. Let me see what we got. I'll probably play with this a little bit more later. Maybe I can do it through here somewhere. Network, wired, settings. Seems okay. Don't know why it would stop pinging. And from PCB, you should also be able to ping 10.1.51, which was the whole point of the exercise, you know. So devices in VLAN 10 was the question. Devices in VLAN 10 can no longer access services on server 1. Fix the problem. So I think we've proved that out. Well, listen, just a quick thing. Thanks for your attention. I hope it was of some value. I know I went through that pretty fast, but it's all good in the end. Take care. Thanks a lot.